morning, student. I am NV Krishna Rao, Assistant Professor, CSE Department. I am handling the compiler design for the 5th semester. So, in the last class, we have seen the regular expressions, NFAs, and DFAs. Now, we'll discuss the conversion between the regular expressions and finite automata. So, now first we'll discuss how to convert a regular expressions to finite automata. So here all these are regular expressions, NFA with epsilon, NFA and DFA. All are interconvertible. So for every regular expression, we can convert to NFA with epsilon. For every NFA with epsilon, we can convert to NFA without epsilon. And that NFA can be converted to DFA. And for every DFA, there exists a regular expression. Right? So all these are interconvertible. Right? So non-NFA is constructed first from regular expression, then to DFA. So and finally a transition table is built. Thomson construction algorithm is to build an NFA from the regular expression, and subset construction algorithm can be applied to convert the NFA into DFA. So the procedure for converting a regular expressions to NFA and then to DFA we refer as Thomson construction algorithm. So the Thomson construction algorithm main aim is a procedure for the conversion of regular expressions to a NFAs and to DFAs. So a epsilon transitions adds nothing since concatenating with the empty string leaves a regular expression unchanged. So concatenation with epsilon is identity operations. Right? So Thomson construction method constructs an NFA from regular expression using the epsilon transitions. So what is an epsilon transitions? Is an empty string, right? So it's a glue or mortar for the components of NFAs. So the epsilon transitions act as a glue or mortar for the components of the NFA. Now we'll see the first conversion part of the regular expressions to NFA with epsilon. Here, the main regular expressions is empty set, empty string, and a symbol A and symbol B. Right? So for empty set, a regular expression empty set, then finite automata will be represented as this one. Right? So empty set, there is no strings in that set. Then empty string, it is the regular expression, its respect to finite automata. Here the regular expression is epsilon, and here this is a finite automata with epsilon. Now it is a regular expression representing a set containing symbol A. Right? Then its respect to finite automata. So there is a transaction on A between the states Q0 to Q1. What this regular expression A represent? A is a regular expression for the regular language or a regular set which has a symbol A. Right? So here that represent a finite automata Q0 on A equals to Q1. Similarly, for B, what is a B? It is a set containing the symbol B. Then its respect to finite automata is Q0 on B goes to Q1. Right? Q0 on B goes to Q1. So here the preliminary operations of regular expressions we are representing with the finite automata. Then here there are mainly three regular expressions. There are mainly three properties on regular expression: union, concatenation, and closure. So for conversion of the regular expressions to finite automata, we use these three properties: union, concatenation, and closure property. So if we know how to convert these properties into finite automata, then for every regular expression will consist either one of these properties. So simply we can convert this one into finite automata. Right? So A plus B, it is a union. A plus B is a regular expression to represent union. So simply in the shortcut form, we represent as this one, and this is the actual one. So the Q naught is the initial state, Q5 is the final state. Right? There are two finite automatas. This is the finite automata 1 represent A. This is another finite automata B. So here we have both finite automatas A and B. We are connecting with Q0 and Q5, and we are adding all these epsilons. Right? Here this is a finite automata 1 represent A. This is the finite automata B representing B. Right? Q3 on B goes to Q4, Q1 on A goes to Q2. These two finite automatas we are connecting with initial state Q0 and final state Q5 with these epsilon transitions. So Q0 on epsilons goes to initial states of first finite automata and our second finite automata. Then from these Q2 and Q4 connects to final Q5. This is a final state of the A plus B, right? So it goes to the Q5, right? So here N of S, N of T are two finite finite automata for some regular expressions. Then we represent this is the first one, this is the second one, and we are connecting with the initial state and final state with epsilon transitions, right? With epsilon transitions. Then another main property of the regular expressions concatenation. We already told regular expressions has mainly three properties: union, concatenation, and closure properties. So union property is completed. Now concatenation property, right? This is the concatenation shortcut form in simple form, and this is the another one. Q naught on A goes to Q1, Q1 on B goes to Q2, right? Here, if there are two finite regular expressions S and C and finite automatas here, this is the first one and this is the second one. Here we have two regular expressions, right? S and T. For the two regular expressions, N of S and N of T are the finite automatas. Then we represent the finite automata for this concatenation property of the regular expression in this form. So initial state connected to the initial state of the first finite automata, then final state of the first finite automata to initial state of the second finite automata, then this final state of the second one considered as a final state of the concatenation of both the finite automatas, right? Q4 is the final state of both N of S and N of T. Okay. So A star, that is the third one, closure property, right? So here A is a symbol which represent a finite automata for regular expression A. So this is the a finite automata for the regular expression A. For the regular expression A, this is the finite. Now what we want to represent? We want represent closure of A. The closure of A, for that purpose, we add one initial state, one final state, and connect with one epsilon, second epsilon, third epsilon, fourth epsilon. By adding these 4 epsilon transitions, we can specify the A star, closure of A. Right? The closure of A will represent as initial state to the initial state of the finite automata, then final state of the finite automata to initial state of the finite automata, then this initial state to the final state, then final state of A finite automata to final state. So these 4 epsilon transitions are connected to convert the A finite automata to A closer finite automata. Right? Is it clear? So the given finite automata is this 2 state. Okay. Here we say as Q naught, this is as a Q1, this is as a Q2, this is as a Q3. Right? If we consider Q1 to Q2 on A is a given finite automata for the symbol A. Now to convert into closure of A, we are adding the transitions. Q naught on epsilon goes to Q1, that is a 1. Then here we add Q naught on epsilon goes to Q3. Q naught on epsilon going to Q3 means 0 occurrence. Right? Q naught on epsilon going to Q1, it may result 1 occurrence. Then Q2 on epsilon goes to Q1, which gives the closure repetition. A is A square, A cube, A3, A4, A power 5, A power 6, A power 7. The repetition will given by this one. Q2 on epsilon goes to Q1. Q2 on epsilon goes to Q1. Then finally, Q2 on epsilon goes to Q3. These 4 epsilon transitions are added for the finite automata A to convert into closure of finite automata. For the closure of A. Right? Now, this is a regular expression. Now we want to convert into the respect to finite automata. What are properties here? This star represent closure property. It will represent union property. Here it indicate concatenation property. There are 3 properties are in this regular expression. Now we will convert this regular expression to finite automata. First we are considering for A. We are representing the finite automata A. So this is the finite automata for the symbol A. Then we are writing the finite automata for the symbol B. Right? We are writing the finite automata for the symbol B. Right? So initial state to final state for the symbol B. Now for the symbol C, we are writing initial state to final state for the symbol C. So we are writing the ABC. We are writing ABC transitions for the finite automata 1, 2 and 3. A for B for C. Right? Now, how to write union? What is the B or C? It's a union property. Simply we are writing union. So, this is the first finite automata for B. This is for the second finite automata. Both finite automatas we are connecting with the epsilon transitions, making it as B union C. So this is the finite automata for the B union C, for the union property. Right? Is it clear? B union C. Then closure of B union C. What is the next? Closure of B union C. Right? So here this one is B union C. This is B plus C, right? And closure of this B plus C. For making that, we are connecting this 1, this is a 2, this is a 3, and this is a 4. We are adding 4 another epsilon transitions to make it B plus C closer, right? How to make this closure property, we consider B plus C as usual, and we add some initial state and some final state, and we connect with 4 epsilons. We are connect with 4 epsilon transitions, right? 1, 2, 3, 4. There are 4 epsilon transitions. Now we got closure of B union C. Here we are getting closure of B union C, right? Now what we required, our requirement concatenation of A followed by closure of B union C, right? A followed by closure of B union C, right? This is the final epsilon, final finite automata, right? So we are writing A connecting with epsilon to this is BRC closure. That's all. This is A concatenation BRC closure, right? This is A represent, it's a finite automata. Concatenation epsilon, then BRC closure. This one will represent as BRC closure, right? Closure of B union C. Then we are adding the A concatenation with B union C closure property, right? Is it clear? Finally, we are getting finite automata A concatenation, that is epsilon, with B union C closure. Here, this one gives this part, right? This part is B plus C, and here this one results B plus C closure, right? This is the conversion of the regular expression to respect to finite automata, right? Now we'll see one more. Here, what is the regular expression? Closure of, union of, concatenation of. A concatenation with B, A concatenation with B, union with A, the complete closure property. Now, we are writing for A, right? We are writing a finite automata for A. This is the finite automata for A. Then, this is the finite automata for B. So, we are writing a finite automata for B. Then, we want AB. What is the first one? AB. A concatenation with B, right? So, simply we are writing A finite automata and B finite automata connecting with epsilon. So, that will result in AB. What is AB? A finite automata concatenated with B finite automata. So, simply we are writing A finite automata and B finite automata. We are connecting with epsilon, right? So, AB is ready. We have written. What is the next? AB finite automata union with A. Union with A. AB finite automata union with A. Then this one is the result. This one is A. This is B. Then this complete one is A concatenated with B. And here this is A. Then what is a union? For union, we add initial state, we add a final state, we connect initial to both the initial state with the epsilon transitions, and from the both the final state to the complete final state with the epsilon transitions. So we add 4 epsilon transition, initial state to both initial states, from the both final states to the final state, right? So we're adding 4 epsilon transitions to make it this AB plus A closure, right? AB plus A. Now we are constructed AB plus A. What is the next step? Closure of AB plus A. What is the next level? Closure of AB plus A. Right? This is the final one. Right? This is the final one. This is AB. This is A. This complete one. AB plus A. Then we add this complete one will result in AB plus A closure. Right? So, one by one, first we have written for A finite automata, then for B, then concatenation of AB, then union with A, then the closure of AB plus A. So, this is the resultant finite automata for the given regular expression. So, this is the final NFA with epsilon equivalent finite automata for the given regular expression, right? So this is the some more problems you can practice, right? Here we'll try one more, A or B, the first one A, right? So we will try the first one. A or B closure followed by ABB, right? What is the problem? A or B closure ABB. That is a given problem, right? First we consider R1 is as A, which says Q1 on A goes to Q2. Like we are assuming the first regular expression is A, then it's an equivalent finite automata Q1 on A goes to Q2. Then we are assuming that second regular expression is B, then Q3 on B goes to Q4. Right? For B we have written. Now, what is next? We'll say R3 once again A, Q5 on A goes to Q6. Then, what is another symbol? R4 is B, Q7 on B goes to Q8. Then R5B, Q9 on B goes to Q10. For all the symbols, we have written the regular expressions and with respect to finite automata. Now, what is the first step? ARB. R1 union R2. Right? R1 union R2. So, what is a R1? Q1 on A goes to Q2. Then, what is R2? Q3 on B goes to Q4. Now, what needed? Union of this both. Union of this both. So, add another states Q11 and Q12. Add Q11 and Q12 as another initial and final states of a union property. Then connect with epsilons. Connect with epsilons. Connect with epsilons. So Q11 on epsilons going to Q1 and Q3, and Q2 and Q4 both on epsilons going to Q12. Now we have constructed for R1 plus R2. What is the next step? ARB closure property. So we are considering some R6, right? R1 plus R2 closure. For the closure property, consider R1 plus R2 first. Q11 on epsilon going to Q1, on A goes to Q2, on epsilon going to Q3, on B going to Q4, on epsilon going to Q12, on epsilon going to Q12. So this is A plus B. Now this union property we have to convert into the closure property. So add two more states, Q13 as initial state, Q14 as final state. Connect with epsilons. Connect with epsilons. Connect with epsilons. Connect with epsilons. Right? We are connecting this as the with the epsilons. So R6 equal to R1 plus R2 closure. Right? So R6 equal to R1 plus R2 closure. Right? Q13, Q14 are the new states considered added to the R1 plus R2 to make it the closure property. Now, what is next? R6 concatenated with R3 concatenated with R4 concatenation with R5. Right? We need next R6 concatenation with R3, R4, R5. Right? So here what required next? First write this one as it is, Q13, then Q11, Q1, Q3, on A going to Q2, on B go to Q4, on epsilons it will reach Q12 to make it a closure property. This is a closure. Q12 on epsilon goes to Q14. Right? Here it runs the Q13 and Q14. Now we have written R6. Concatenation means epsilon with R3. So Q5 on A go to Q6. Concatenation. So epsilon. Q7 on B goes to Q8. Concatenation means on epsilon going to Q9, on B going to Q10. right? This is the completed NFA with epsilon or finite automata for the given regular expression. So this is the our given regular expression which is to be converted to finite automata. Then these are the procedure steps to convert a given regular expressions to the final finite automata by using the three basic properties: union, concatenation, and closure properties. Right? So here with this one, I'm closing this class, and in next class we'll discuss the other topics. Okay, so this conversion of regular expressions to finite automata with these three examples we are discussed. Okay, thank you. I'm closing the section.
Like, share and subscribe. Hit the bell icon for more updates.